Hello, it is my great pleasure to make a presentation about Intel Neural Compressor, a scalable quantization tool for ONNX models. Intel Neural Compressor is an open-source Python library running on Intel CPUs and GPUs. It delivers unified interfaces across multiple deep learning frameworks for popular network compression technologies, such as quantization, sparsity with pruning, and knowledge distillation. The left diagram shows the architecture of Intel Neural Compressor. The top is acceptable FP32 framework models. Middle is the Intel Neural Compressor, containing many user-facing APIs and key compression components. It is built above deep learning frameworks, including TensorFlow, PyTorch, ONNX, and MXNet, and can yield a compressed framework model for deployment. On quantization side, it unifies different quantization APIs of different deep learning frameworks and provides an out-turning mechanism to help users figure out the best low-precision solution on Intel hardware rapidly. The right diagram shows the workflow. It takes FP32 framework model, calibration dataset, evaluation dataset, and evaluation metric as inputs. After backend independent pre-optimization, it queries framework's quantization capability and constructs an OP-wise quantization turning space. With some strategy, it picks up one of quantization configuration and generate a quantized model by invoking framework quantization interface. It will evaluate the accuracy of this quantized model and checks if it meets predefined accuracy goal. If it doesn't meet this goal, the turning strategy will select the next quantization configuration and generate a new quantized model. This flow will keep working till it finds out a quantized model meeting accuracy goal. Next, I will show how to deploy ONNX model quantization with Intel Neural Compressor rapidly. There is an example of config file and launch code on the right side. Since the launch code is generic, user just needs to update some minimal items in the blue boxes. And then the tool will construct a quantization pipeline with built-in datasets, transforms, and metrics according to the settings of config file automatically. It can speed up the process of quantization greatly by reducing preparation of inference code and quantization pipeline construction of specific framework. There are many typical built-in datasets, transforms, and metrics in this tool, which can cover most computer vision and some NLP tasks. For example, user can organize the image folder dataset, resize transform, and top key metric to build an image classification pipeline. Thanks to these built-in components, user can quantize a model with just 5 lines of code and minimal changes in config file. For more detailed instructions, please refer to Intel Neural Compressor GitHub repo. Now let me show our contributions to ONNX Model Zoo. This table shows our status in ONNX model quantization. It includes widely used computer vision models like ResNet 50, VGG16, and ShuffleNet V2, as well as some typical NLP models like BERT, RoBERT, and DistillBERT. Compared with their FP32 baseline, the quantized models have smaller size, performance improvement, and less than 1% accuracy drop. It can make great contributions to productivity. Until now, ResNet 50, VDD16, and ShuffleNet V2 have been upstreamed to ONNX Model Zoo, and we got positive feedback from Model Zoo owner. He said Int8 ResNet 50 is the first quantized model for ONNX Model Zoo, and it shows great performance improvement. Other models are working in progress, and we will submit them soon. This is our contribution plan. We plan to contribute more quantized models in the future, which will enrich the diversity and scale of Int8 models in ONNX Model Zoo. Our goal is all enabled FP32 models in ONNX Model Zoo would have corresponding quantized models through Intel Neural Compressor. In the first stage, we will focus on image classification, domain-based image classification, object detection, and image segmentation models. Then, in the second stage, we will mainly focus on machine comprehension, speech and audio processing, image manipulation, body, face, and gesture analysis models. Also, we will reach more quantization strategies and improve API design to make Intel Neural Compressor more powerful and easier to use. Well, that's all of my presentation. Thank you for your time.